Hello everyone. Today we are going to learn about TabPy, that is Tabular with Python. Uh, the presenters are myself, that's Nisha, my friends Sanjana and Val. So I would like to first take you over the agenda. So we are going to learn about Tabula, what is Python, TabPy server, installation of TabPy, benefits of using Tabula, benefits of using TabPy, Python functions, that is script real function, script str function, script int function, an example of a Seattle police which illustrates the TabPy. So first let's start with what's Tabula. Tabula is a powerful business intelligence and data visualization tool that has a very intuitive user interface. It is very useful in drilling down data, creating insightful reports, and granular, actionable business insights. Tabula Business Intelligence and Data Visualization tool has been placed in the leaders quadrant for the fifth year in a row in 2017 in the business intelligence and analytic platforms by the IT research firm Gartner. Gartner has positioned Tabula as highest in the ability to execute again this year when it comes to the aspects of intuitive analytics and interactive visual analytics. It cannot get any better than Tabula. So the next thing is, what is Python? Python is a widely used general purpose programming language popular among academic and industrial alike. It provides a wide variety of statistical and machine learning techniques and is highly extensible. Together, Tabula and Python is a data science dream team to over any organization's data analysis needs. In 2013, Tabula introduced the R integration, the ability to call R script in calculated fields using R server. With the release of Tabula 10.1, we can use Python script as part of our calculated fields in Tabula, just as we have seen and been able to do with R. The Python integration happens through the Tabula Python server, that's TabPy. So, Tabula Python server is a part of Tabula's expanding range of extensibilities options. The TabPy framework allows Tabula to remotely execute Python code. It has two components: a server process built on Tornado, which allows for the remote execution of Python code through a set of REST APIs. Code can either be immediately executed or presented in a server process and exposed as a part of REST endpoints or to be called later. A client library that enables the deployment of such endpoints based on Python functions. Tabula can connect to the TabPy server to execute Python code on the fly and display results in Tabula visualization. Users can control data and parameters being sent to TabPy by interacting with the Tabula worksheet, dashboards, or stories. Next is, let's go through the installation of TabPy. So for the installation of TabPy, you need to go to our GitHub link provided over here, or you would have a download button in the upper right corner on the GitHub link for the TabPy repository page. Downloading and should be downloading the zip file and extract it up, and it is always been updated by the community team with the new processes. The whole step-by-step procedure is also being given on the GitHub link. More information on how to configure and write calculations also on official documentation, which also talks about how to use table calculation, addressing, partitioning, settings correctly. This all is being illustrated on the GitHub link. So next, when you are proceeding with the installation steps, you could see one when the installation is completed, you could see the black screen which says that installation is being completed. And to connect the TabPy with Tabula, you have to configure it. So you can configure the TabPy connection on Tabula. You could go through the help menu in the Tabula desktop, choose the setting and performance, go under the manage external services connection to open the TabPy connection dialog box and enter over the details over there. So next we are going to see what are the benefits of using Tabula. So, Tabula is a data visualization tool first and foremost. Therefore, its technology is there to support complex computations, data bending, and dashboards for the purpose of creating beautiful visualization that deliver insight that cannot easily be delivered from starting with a spreadsheet. It has climbed to the top of the data visualization heap because of its dedication to this purpose. Quickly creating interactive visualization. Using drag and drop functionalities of Tabula, users can create a very interactive visual within minutes. The interface can handle endless variations while also limiting you from creating while also not limiting just from creating the charts are against the data and visualization, which are also known as the best practices. Enhanced user interface using Tabula. There are many different types of visualization options available in Tabula, which enhances the user experience. Also, Tabula is very easy to learn. Anyone without having knowledge of coding can easily learn Tabula. Tabula can handle large amount of data. Tabula can handle millions of rows of data with ease. Different type of visualization can be created with the large amount of data without impacting the performance of the dashboard. Also, there is an option in Tabula where you can make live to connections to different data sources like SQL, etc. Use of other scripting languages in Tabula is also there. So you can use Python or R. Using Python scripts can make the load of the software by performance task in this package. Next, we are going to see what are the benefits of using TabPy. Python gives access to a wide variety of machine learning libraries and allow you to call out to web services. It sends the data in tabular dashboard to Python to do that. It has new capabilities like predicting churn or converting text data to sentiment scores or finding the optimal route for delivery trunks. The next we are going to talk about the Python function.
Hi, this is Sanjana Jami. Let's continue with my slides. Python functions. In order to let W know the calculations need to go to Python, it must be passed through one of the functions. Python functions are computed as table calculations in W. Aggregate measures include min, max, ATTR, sum, median, and any table calculations are Python measures. Python, Python functions are script bool, script int, script real, and script string. So I'm going to explain about these four functions in my further slides. Let's talk about script real function. This function returns a real result from the specified expression. The expression is passed directly to a running external service instance. In this example, placed from the right side of my slide, I have taken the data source from sample superstore, and as the dimensions I have chosen category and segment, and as the measures I have chosen sales and profits, which are used as an arguments. So these two arguments, argument 1 and argument 2, are passed into the core cof function. So basically the core cof function returns a matrix from the correlation coefficient is extracted so that the single column is returned. And in this example, each point in a scattered plot represents a customer, and tab py is receiving sum of sales and sum of profit for each customer. W aggregates the data before sending to tab py using the level of detail of the view. Coming to the next function, which is script string, is used to return the value of array. This example shows how the two strings are being concatenated by using the Python script. For this, I have chosen category and subcategory and placed both of them in the rows shelf. I wanted to combine these two strings and wanted to display it with the future, like for example, furniture and bookcases. I wanted to display it like furniture bookcases. So for this result, I have used script string function in the table calculated field of tableau, and I have taken the range from 0 to length of the argument, and I have passed two arguments as an object, like argument 1 plus argument 2 into the lst.append, which this function basically updates the values in the existing list, and this value is being returned, and then it displays by using attr aggregate measure. Attr is used in the code to return the value of given expression if only has a value for all rows in a group, otherwise it displays asterisk. Script int function is used to return the value of integer from the specified expression. The expression is passed directly to a running external service instance. In this example, the Python script is generated in the calculated field of tableau, and I wanted to use any arithmetic operation to display the value based on the integer. So for that I have chosen category and subcategory dimensions, and as a measure I have chosen sales value. For this example, I chosen to multiply each value by 2. So, so each value is being considered as I in this code, and it is multiplied with 2, and it returns the values with the measures with the measure of sum of sales. We can see in the sheet by after it multiplies, it displays the each row with the value multiplied by 2. And the final function is script bool function. It is used to return the value of boolean from specified expression. To identify value is positive or negative, this script bool function helps to get the result as needed. In this example, argument 1 is equal to sum of profit, and I have I have taken the dimensions, and I wanted to see the values of these both dimensions have whether positive or negative. So in for that case, a boolean function helps. So I have written the condition like if the value is greater than 0, it should display with the positive result, otherwise it should display with the negative value. That is the major concept for the script boolean. So this is how we can use the functions by using the Python script, and with connected to Tableau. Thank you.
Now let's talk about building advanced analytics applications with TabPy. Python is a widely used general-purpose programming language, popular among academia and industry alike. It provides a wide variety of statistical and machine learning techniques and is highly extensible. Together, Python and Tableau is the data science dream team to cover any organization's data analysis needs. When you pair Python's machine learning capabilities with the power of Tableau, you can rapidly develop advanced analytics applications that can aid in various business tasks. Here we have an example that includes a real data set from Seattle 911 police calls incident response data for the past 6 years. The dashboard highlights the hotspots because there is a lot of activity. For example, you want to focus your efforts on patrol cars in certain places. You don't want to look at thousands of events, you just want to know what is the best area for improvement. For this, we break it into different types of crimes, and you can see that there is some criteria like average incidents per quarter. Does it have to have at least 2 incidents per quarter to be qualified as a hotspot? And what the proximity tells us about the distance between incidents? If there are 5 incidents within 100 feet of each other, does it make them a cluster of incidents? Is that a hotspot, or is 200 feet or 300 feet better? These could change dependent on where the analysis happens. For example, in a rural area, you may say maybe 500 feet is good enough, but in a more condensed area, more dense city area where city blocks are smaller, there is a lot more activity. Maybe 200 feet is a better idea. If we change this from 300 feet to 200 feet, then it's a more tight criteria. Clusters are getting smaller. We can relax it by saying one incident is enough. That will give us more points. Let's justify the dashboard. We have an original data set with a point for each criminal activity to happen in Seattle area. If you plan on visiting Seattle, at some point you can look at spots that you should be avoiding. In this case, we have a filter. We can swap between different activity types. What we are seeing here are criminal hotspots out of many thousand points. We're finding points where there is a lot of dense, high number of activity nearby. Assault, threats, harassment, residential burglary, narcotics, liquor violation, parking violation. We can see that there are some interesting hotspots. We parameterize this because, for example, a police officer may have different criteria for what qualifies as a hotspot. They may think that there has to be at least 1 incident per quarter within 200 feet. Under the covers, we are running Python code to answer the question. Let's look at the hotspot calculation. We're using script string function in this case. In the calculated field, we can see that the calculation contains plenty of Python code. We're passing Python code between quotation marks. It has a method called dbscan, which is great for looking for dense and sparse areas. It handles noise really well and also works really well on maps. It uses NumPy. It also uses scikit-learn, which is very popular machine learning library. It passes our latitude, longitude, and distance between incidents and incident count as inputs to the model. dbscan algorithm is really good for this kind of mapping applications. It is also good for clustering when the data has noise. This is actually a clustering algorithm that returns cluster number or outliers. It looks at clumps of data. We filter out outliers and just return the clumps. Let's talk about dbscan. Density-based spatial clustering of applications with noise, dbscan, is a well-suited algorithm for this job. It is also installed conveniently by default as part of TabPy. It takes two parameters. One to specify the maximum allowed distance between points for them to be considered part of the same cluster, and one to specify the minimum number of nearby points to constitute a cluster. This allows for experimenting with different values of distance and event frequencies criteria. Different options can be more appropriate for downtown Seattle versus the suburbs, a police officer looking for hotspots versus a tourist looking for places to avoid, or a tenant looking for houses to rent or buy. So let's see how Tableau and Python work together. We're using Excel as our data source, but many different kinds of data sources can be used. Since our calculations and Python calculations are local calculations, it is independent of the data source we are connected to. This works on Tableau desktop and server. Tableau leads into Tableau product from the data source, and then data is inside the sheet. That is what is being passed to Python for processing. If visualization is an aggregate visualization, we will pass the aggregated data. If the aggregate measures option is unchecked, then we will pass this aggregated data. Whatever we see in the visualization marks the values for those marks. That is what we are passing to Python. External services cover rserv and TabPy, that are the components that we use to talk to Python. We send the scripts along with the data, and we get some results data back and display it in Tableau. We return one column as a result. In this case, we return the column that we're using on the color shelf and the filter shelf. Thank you very much.